Okay, so the question's on page 559. Number 15. A boy is twirling a 155-gram ball on a 1.65 meter string in a horizontal circle. Okay, so the circle is like this. It tells us the mass of the ball is 155 grams, which you do have to change into kilograms, so 0.155 kgs. Tells us the radius of the circle is 1.65 meters. And it says the string will break if the tension reaches 208 newtons. So the FT, the max it can be is 208 newtons. And then it wants to know what's the speed it can go at. So remember, FC is equal to mv squared over r. And so Ft is the centripetal force in this case, is equal to mv squared over r. And the 208 is the maximum speed you can have. So, or maximum force you can have, and you want to find the speed. So rearrange for v, so take your r up and your m down. So v squared is equal to r times ft over m. So 1.65 meters times 208 newtons divided by 0.155 kilograms. And remember, what you're going to get there is going to be v squared. You should get 2214.19 meters squared per second squared, and then take the square root. So 47.06 meters per second. That's pretty good. That's a pretty good speed. 40. Yeah, that's getting close to 180 kilometers per hour. He's got a pretty good clip going there. Number 16. An electron, mass of 9.11 times 10 to the negative 31 kilograms, orbits a hydrogen nucleus at a radius of 5.3 times 10 to the negative 11, I think. Yeah, 5.3 times 10 to the negative 11 meters. At a speed of v is equal to 2.2 times 10 to the 6 meters per second. Find the centripetal force. So Fc is equal to mv squared over r. 9.11 to the, there is a negative on that 31. This electron is not massive. 31 kilograms. V 2.2 times 10 to the 6 meters per second. Remember to square it when you type it in your calculator. And 5.3 times 10 to the negative 11 meters. And when you do this, you should get a force of 8.319 times 10 to the negative 8 newtons. Number 17 was the one I said could be a little bit tricky, and it's because it's a vertical circle. Okay, so here it is. And it's a stone. So it tells us a stone of mass 284 kilograms, so 0.2 or grams, so 0.284 kilograms, is twirled at a constant speed, so v is 12.4 meters per second, in a vertical circle of radius 0.85 meters. So part A says what will be find the tension at the top. So A is at the top. So at the top, Fg is acting down, and so is Ft. So we do sum of the forces, or Fc, is equal to mv squared over r. This is for A. So towards the center of the circle is positive, so it'll be Ft plus Fg is equal to mv squared over r. So Ft will equal mv squared over r minus mg. So Ft equals 0.284 kilograms times 12.4 meters per second squared over 0.85 meters minus 0.284 kilograms times 9.81 meters per second squared. And you're going to get an Ft. The first term is 51.37 newtons. The second term is 2.786 newtons, and you get an FT, when you subtract those, 48.59 newtons. Works out to be positive, so towards the center of the circle. That's part A. Part B wants to know what's the tension at the bottom. So at the bottom, Fg is going down away from the center of the circle, and Ft is going up. So when we do B then, and we do sum of the forces is equal to mv squared over r, we get Ft minus Fg is equal to mv squared over r. So Ft is going to equal mv squared over r plus Fg. And they're exactly the same as what's up here. It's just up here it was in A, it was subtracted. In B, it's added. So I don't really have to fill all my numbers in. I can cheat and go down to 51.37 newtons, and this time it's plus 2.786 newtons. And so I get an Ft to be 54.16 newtons. And again, it's positive. It's towards the center of the circle. And there's a part C that says, what maximum speed, what is the maximum speed the stone can have if the string will break when the tension reaches 33.7? Stone's going to break at the bottom. The string's going to break at the bottom, right? Because that's where it's going to be biggest. So at the bottom, when we do sum of the forces is equal to mv squared over r, it'll be Ft minus Fg is equal to mv squared over r. And this time you're solving for v. So multiply both sides by r and divide by m. So Ft minus mg, multiply both sides by r, divide by m. So v squared will equal, says the string will break at 33.7 newtons. My mg that I wrote down up here was 2.786 newtons. I'm going to multiply that by the radius, which was 0.85. The whole top has to get multiplied by that. And then divide it by 0.284 kilograms. And again, remember when you do this, that's v squared. So you get a v squared of 92.52 meters squared per second squared. Take the square root and you should get a v of 9.62 meters per second. That is the speed where the string will break at the bottom. Okay? Number 10, you were driving a 1654 kilogram car on a level road, start to round a curve at 77 kilometers per hour. So you have to change your 77 kilometers per hour to meters per second. And when you do, you get 21.38 repeating, I believe. Okay? If the radius of curvature is 129 meters, so 129 meters, what must be the frictional force between the tires and the road, right? So again, it's your frictional force that is supplying Fc. And so really they're just asking you what is Fc. So mv squared over r. So 1654 kilograms times 21.38 repeating meters per second squared divided by 129 meters. And you get a force of friction to be 5,865.73 newtons. And the last one, number 11. Stunt driver has a car mass 2545 kilograms, begins to skid, force of friction is 1.75 times 10 to the 4th newtons. Speed is 24 meters per second. What is r? So FFR is equal to mv squared over r. R is equal to mv squared over f. And you should get, I'm just going to hop down here in case I run out of time, 102, whoops, no, wrong question, 83.77 meters. So you do your two